Hey everybody, in this lesson we're going to talk about structural isomers and cycloalkanes. Now what structural isomers are branches that join the main alkane group. So what are alkyl groups and branches? Well, what we know is that hydrocarbons do not need to just be one single chain. They can have branches. And we call these branches alkyl groups. Which means that depending on the length of the branch, the ending of branch becomes -il. So not ane anymore, but -il. So YL. Branches are always the shorter path. But they could be as long as they need to be. So an example of this would be, for example, if there's a branch that said, let's say for example, a butyl group. Butyl, if I were to write the condensed formula or condensed structure, will be written as CH2. So here's a branch CH2, CH2, CH3. So in this case, this part will connect to the main chain, the main alkane chain. So here's a table showing you a lot of the more common branches, such as for example, here's a methyl group, which is just one methane connected to the main chain. Here's an ethyl group, a propyl group, a butyl group, which is what we just drew, as well as a pentyl group. So how do we name branches? How do we name branches so that we understand what it means? Well, here's the thing though. The first step is find longest chain first of carbons. This is what we call our parent chain. Okay, number 2. Number your carbons, number your parent chain carbons. So that the branch is in the lowest combined number. Okay, number 3. List alkyl group and their number before parent name. Number 4. Put them in alphabetical order. Which means that ethyl comes before methyl. And what you could end up with is number 5, put dashes between number and alkyl groups or alkyl branches. Now number 6, okay? If more than one of the same branch, put both numbers and add di or tri before alkyl name. So there's a lot of steps here, but once we get to naming them, it'll become a lot easier. So let's go over this. So step 1, find the longest chain of carbons. That's your parent chain. Step 2, number your parent chain carbons so that the branch is the lowest combined number. Number 3, list your alkyl groups and their numbers before parent name. Put them in alphabetical order. Put dashes between the numbers in the alkyl branches, and if more than one of the same branches, put both numbers and add di or tri before. So let's try this out. Let's look at this first example. This first example here is your first step is find your parent chain. Well, if you look at this, you have a carbon here, 1 carbon, 2 carbons, 3, 4, 5, 6, 7. That is your longest chain, because there's no other chain that could be longer than 7, because if you go here, 1, 2, 3, 4, 5, 6, that's only 6 right here. You go 1, 2, 3, 4, 5, 6, that's still 6. 1, 2, 3, 4, 5, 6, 7. This is 7 right here, but remember, this carbon has free rotation. These two could just swap around. So 7 is my longest one. So we know that this parent chain, the parent here, is equal to a heptane. Okay, so where are my branches then? Well, my branches are, right, so I'll highlight them in green. Here's one branch. Here's one branch. Here's another branch. And here's another branch. Okay, so there's 3 branches right there. Now you want to number your parent chain in where that your branches are the lowest set of numbers. So if you go this way, 1, 2, 3, 4, 5, 6, 7, your branches are on carbon 4, carbon 5, and carbon 6. Is there a shorter way? And there is. Because what if I go backwards? You gotta go 1, 2, 3, 4, 5, 6, 7. In this case, my carbons are now on, my branches are now on 2, 3, and 4. Way lower than 4, 5, and 6. Okay. So now it's time to name these branches. This one right here is called ethyl group because it's from an ethane. These two are called methyl groups because they're single carbon. So in this case, how do we name them? Well, our first step is we want to put them alphabetically. Our ethyl group should come before our methyl group. Now where is our ethyl group located? It's located on the 4th carbon. So we write 4-ethyl. See the dash and the number. Now we put another dash. And now we want to name our second type of branches, which is a methyl group. There's a methyl group here, and there's a methyl group here. Because they're both the same type of branches, we can name them together. So we have 2, 3 dimethyl because there's 2 methyl groups. And then last but not least, our parent chain, which is heptane. So if I was a chemist and I was reading this, I could read this as there is an ethyl group on my 4th carbon of parent chain. There are 2 methyls in my 2nd and 3rd carbon, and it's a heptane. My parent is a heptane chain. Let's look at the next example. So in this example right here, what is my parent chain? Well, my parent chain here is, if I number these carbons, 1, 2, 3, 4, 5. Okay, 5 is pretty long, but is there a longer one? And there is, because I could go 1, 2, 3, 4, 5, 6. 6 is my longest one, so I'll highlight my parent chain like so. Here's my parent chain. Which means I have 2 branches. They're both methyl groups. Okay, now I need to number my parent chain in which it's the lowest set of numbers. So if I go from this direction, 1, 2, 3, 4, 5, 6. Okay, that's one way. The other way is 1, 2, 3, 4, 5, 6. What do you notice? In this example right here, what you notice is that my numbers doesn't matter. Because they're both methyl groups, they're the same groups, they're both on the 3rd and the 4th carbon, it actually doesn't matter. So what we have here is in this case, we start off with our branch, which is our 3rd and 4th carbon. There's 2 methyl groups, so it's dimethyl hexane, because our parent group is a hexane. So our parent, if you want to write this down, our parent equals hexane. Okay. So let's look at our last example. In our last example right here, what we see is, first of all, let's find our parent chain, our longest chain. So if we were to count this, we have 1, 2, 3, 4, 5, 6. Okay, that's a hexane group over here. So is there a longer one? Okay, let's see. 1, 2, 3, 4, 5, 6, 7. There's a heptane group right here. So this is our longest chain, our heptane group. So being that our heptane group is the longest chain, that's our parent chain. So that is our parent this time, again, is heptane. Okay, what are my branches? Well, in this case, I have a methyl group and I have an ethyl group here. What carbon is it on? Well, if I go for this direction, I'll go 1, 2, 3, 4, 5, 6, 7. Or if I go backwards, it's 1, 2, 3, 4, 5, 6, 7. Okay, you can see that it doesn't matter. It's on the 4th carbon. So how do I name this? Well, you first got to start alphabetically. So it's 4-ethyl. Ethyl is alphabetically before methyl. 4-methyl, because it tells you on the same 4th carbon there's a methyl group, heptane. The parent chain is a heptane group. Okay, so that right there tells me that this is the 4-ethyl, 4-methyl heptane. Okay, so hopefully this makes a bit more sense. Again, if you are getting stuck on these, there's a lot of practice questions you could definitely work on. Let's try the next example. In this example here, we're working backwards. What happens if you're given the name? Can you draw the structure out? Well, let's see. In this example here, what we see is, first of all, let's highlight some stuff. Here's our parent chain. It's a hexane. Here's our first branch. It's a 3-ethyl group. And then here's our second branch. It's 2,3-dimethyl. Okay, let's try this out. So first of all, let's draw our parent chain. Our parent chain is, so what I want to do is I just want to draw my backbone. Carbon, 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 and carbon. Okay, I haven't filled out any H's yet because we don't know how many H's there are. Okay. My next thing is to knowing if I know to number these. This is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. There is an ethyl group on my 3rd carbon. So right here there's an ethyl group. So I gotta write CH2, CH3. That's what an ethyl group is. Okay. So there's my ethyl group. Okay. On my 2nd carbon, there's a methyl group. So right here, there's a methyl group. Done. But also on my 3rd carbon again, there is another methyl group. Done. So what I have to do last? Fill out the rest of the carbons with its hydrogens, because each carbon member can have up to 5 bonds, or 4 bonds I mean. So in this case, what you have here is the first one, this one's CH3, because if it already has 1 bond with the carbon, it has 3 more bonds for the hydrogen. This carbon already has 1, 2, 3 bonds, so this one is just a CH. This middle carbon, the 3rd carbon, already has 1, 2, 3, 4. It's already satisfied. It actually has no carbons attached. This one has 2 carbons attached, so it's CH2, CH2, and CH3. What you're going to notice is that the last carbon is always H3 if it's saturated. So in this case, it is CH3. It has, but the middle carbons are always H2s if they have nothing else attached to it. Okay, let's try the next example. 3,4-diethylhexane. So again, the parent chain is a hexane. The 2 branches are ethyl groups. So let's draw it up. Here is my hexane. Okay. On the 3rd and 4th carbon, so if I number these carbons again, 2, 3, 4, 5, 6. Okay, if I number these carbons again, on the 3rd and 4th carbon, there are ethyl groups, which means it's CH2, CH3, CH2, CH3. The rest of the carbons have, in this case, hydrogens attached to it. So this terminal carbon has 3 hydrogens attached to it, so it's CH3. This one has 2 carbons attached to it already, so it's CH2. This one already has 3 carbons attached to it, 1, 2, 3, so it is CH only. So this one's CH. Likely this one, 3 carbons attached to it already, it's CH, This one has 2 carbons, so it's CH2, and then 1 carbon, CH3. Remember, carbon can only have 4 bonds max. So let's look at the last example here. In the last example here, what you're going to notice is that you have a parent chain of an octane this time. So you have octane. So let's draw our parent chain. C, 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 C. Octane means 8. So 5, 6, 7, 8. Okay, there's 8 carbons. Alright, my next thing that I have here is, well, what are my branches? My branches that I have involved are, the first one is 3,6-diethyl. That means on my 3rd and 6th carbon, there's ethyl group. On my 4th carbon, there's a methyl group, and last but not least, on my 5th carbon, there's a propyl group. Alright, so let's number these. If this one is carbon 1, that means this one's 3, 4, 5, 6, 7, 8. Okay, so on my 3rd carbon, there is a ethyl group, CH2, CH3. On my 6th carbon, so 1, 2, 3, 4, 5, 6, there's another ethyl group, CH2, CH3. On my 4th carbon, there is a methyl group, so CH3. On my 5th carbon, there is a propyl group, which means it's CH2, CH2, CH3. So there are my carbon groups. The last thing I do now is fill up the rest of my hydrogens, which look like this. So this is a terminal carbon, so it's CH3. This one already has 2 bonds, so it's CH2. This one has 3 bonds, so it's CH. 3 bonds, CH. 3 bonds, CH. 3 bonds, CH. 2 bonds, CH2, and 1 bond, CH3. So this you can see right away from the name and the formula that there's an ethyl group in the 3rd carbon and a 6th carbon. There's a methyl group on the 4th carbon, and there's a propyl group on the 5th carbon. Okay. So let's move on to the next example. So how does carbon bond again? Well, remember, carbon has 4 bonds. If it's just carbon by itself, they will be CH4. If it's carbon plus 1 carbon, they will be CH3. Carbon attached to 2 carbons, this will be like those interior ones, it's CH2. Carbon plus 3 carbons, this will be CH, and then last but not least, carbon plus 4 carbons, this would just be carbon by itself, a C. Okay. So what are structural isomers then? Well, structural isomers are a special type in the sense that what are isomers? It's where the molecular formulas are the same, but the structure isn't due to the branches. So molecular formulas are the same, but the structure is different due to branches. Let's show this with an example of C5H12. So there's actually 3 ways to draw C5H12. Okay, the easiest one for sure is if you just draw it as a linear structure. So if you just draw, so I'm going to draw this one going downwards. So C, 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 and a C. Okay, so in this case, this one is CH3, CH2, 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 CH3. Okay, that's the most simplest model we can draw. What happens if we take this carbon and let's take it off the section and, for example, attach it to here? If we do that, so this is our first one, the second one we're going to get looks like this. You're going to have CH2, or no, CH, C, 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 and a carbon sticking out there. So now you're going to have CH3, CH, CH3, CH2, and CH3. Okay, is there one more way I could do this? Can I take this carbon, maybe for example, and attach it to here? If I do that, I actually get the same structure back out. And if you don't trust me, try it out. If you take this carbon right here and attach it right here, you're going to form this long chain here, and then with a branch sticking out here. So it doesn't work. What's the last one I can do? What happens if I take this carbon and attach it to here? What happens if I take this carbon and attach it right there? That's my third carbon, or third isomer. It will look like this. Carbon, 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 and carbon. So I get CH3, 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 and CH3. As you see, each of these are still C5H12. I still have 5 carbons and 12 hydrogens, because each one will have 12 hydrogens total. But each of their names are different, because this one will be called pentane. This one will be called 2-methyl, okay, because it's on the second carbon, 2-methyl butane. And this one right here will be called 2,2-dimethyl, 2,2-dimethyl propane, which actually has another name. Some people call this one neopropane, or neopentane. Their name they call it is neopentane. Alright, but these are what we call structural isomers. They are the same chemical formula, but drawn 3 different ways because of their branching. Okay. What are the properties of alkanes then? So the properties of alkanes, well, they differ. Due to the length of the carbon chain, the properties will change. Okay, so for example, from CH4 to C3H8, that is a gas. These are gases. So methane, ethane, and propane are gases. Okay, C5H12 all the way up to C15H32, these are liquids. Like, for example, certain types of alkanes will be liquids in this state. The last one is anything larger than C16H34 and greater, okay, will be solids. Like, for example, fats and other types of organic compounds are that long. To finish up today, we have 2 more types of alkanes we're going to talk about. The next one is called cycloalkanes. Okay, cycloalkanes are where the alkanes are attached in a loop, which is where this word cyclic come from. So this is called C3H6. As you can see, each of the carbon is connected in a cycle. C3H6. What you notice is that in a cycloalkanes, each of these these hydrocarbon groups, are all attached as CH2. All carbons can only have max CH2 in the cycle. So how do we name cycloalkanes then? To name cycloalkanes, we name them the same as before. So the big thing is same as straight chains. But now we add cyclo in front of parent chain. If it has branches, number the branches. Okay, and the last thing here is exception. There's an exception here. if only one branch, no number is needed. Okay, so let's take a look at example number 4. Let's draw the structural formula of ethyl cyclohexane. So what that means is you have, for example, here you have the parent chain is a cyclohexane. Okay, so how do you draw cyclohexanes? Well, what you have is you have a carbon attached to another carbon, so 6-sided, to another carbon, to another carbon, to another carbon, to another carbon, and that's it. Why there's no number attached to the ethyl is because there's only one branch. Because one branch, the ethyl will go anywhere because you can, in a sense, rotate this carbon chain and it will not change. The branch can be anywhere. So let's put the ethyl group here. So you have, now let's put it here, CH2, CH3. That means the rest of these will have carbons, or no, hydrogens attached to it. So this will be CH, CH2, 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 and CH2. So what you're going to notice here is that is ethyl cyclohexane. Now there's another way we could draw it. We could draw like a skeletal formula, where it's just drawn with lines. Okay, where we assume every corner of these lines is a carbon. So I could draw a hexagon where each of these corners is a carbon, and I could do the same with my ethyl group. So CH2, CH3. So that's the other way I could draw it, and it could be a lot quicker. So if you look at this example here, you can see this example. This is how we'll name it. So you want to name this molecule, so you see how there is two methyl groups, so here's a methyl group, here's another methyl group, and it's at 1 and 4, and here's an ethyl group, it's at number 2. So to name this one, again, we're going to name it alphabetically. So we have 2 ethyl, because more than one branch, we need the number. 1,4-dimethyl cyclohexane. The last thing we're going to talk about today is, what are alkyl halides? So halides comes from the words halogens. Alright? So they come from the word halogens. And they come from the word halogens because alkyl halogens have a valence equals 1, like hydrogen. Because of that, they could almost in a sense act like hydrogens and bond as branches. They can be branches too. So we still name them. How do we name them? We still use the same style of naming them. But the alkyl halides end in O. So for example, fluorine becomes fluoro. Bromine becomes bromo. Okay. So they can become branches too. So let's take a look at this next example to practice it out. So if I look at this, I see my parent chain is an octane. It's just a straight chain octane, so let's draw that out first. So you have carbon, 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 number 5, 6, 7, 8. Okay. On the 4th carbon, I have a fluoro group. So on the 4th carbon, there's a fluorine attached to it. On the 2nd carbon, I have a bromine group. So there's a bromine attached to it. Okay. On the 3rd one, I have an ethyl group. So it's CH2, CH3. So what I have left is the rest of them are just hydrogen. So CH3, CH, 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 CH2, H2, H2, and H3. Now can we also do this, what we did earlier with the skeletal, with these straight chains? And the answer is yes, we can actually do that as well. How does that look like? Well, because these are drawn like bents, I could draw like this, where right here, if I draw a straight line like this, just a straight line like this, what I'm going to get is there's actually a carbon on each end. There's a carbon there, and there's a carbon there. So what if I keep drawing these straight lines? Oops. There's another carbon right here. So if this is just it, this would be propane. This will be butane, pentane, hexane, heptane, and octane. Where each of these corners is a carbon. Okay, each of these corners is a carbon. So that means again, on the second carbon, that should be Br by the way. On the second carbon, there's a bromine. On the third carbon, there's an ethyl group. On the fourth carbon, there's a fluorine. And that's how you could draw it like a skeleton. Let's finish up today's lesson on what is the name of this molecule. So if we look at this one, the parent chain here is, as you see, propane. Where is the chloro group attached to? The second carbon. So it's 2-chloro propane. Just telling us on the second carbon, there's a chlorine group. So what are the properties of alkyl halides? Well, it depends. It depends on where the halogen is bonded to. Because if you just by moving, for example, just by moving this fluorine to another carbon, can actually change the property. As always, make sure you keep yourself safe and healthy, and I'll see you soon.